Hi there, Mr. Muhammed is here. We are going to talk about inequalities, Unit 5.5, page 191. So the very basic thing about inequality is about comparing two quantities, sometimes numbers or two expressions. So we just compare them, which one is greater than the other one. So some worked examples are here. The first one, if you look at here, we have -2 and 1. So definitely 1 is greater than -2. For this one, we have -2 squared, which is equal to 4. And for this one, we have 1. Definitely 4 is greater than 1. 1/5 and 1/4, comparing fractions, when they have the same numerator, we look at the denominators. So the greater denominator is the smaller. If you use calculator, since calculator is allowed, divide 1 by 4, you see 0.25. Divide 1 by 5, you see 0.2. So 0.25 is greater than 0.2, which is 0.20. 25 is greater. So these are very basic questions. For example, this one, -1 squared will be positive, and -1/2 square will be positive 0.25. So definitely 1 is greater. Pi is 3.14. Pi square will be more than 10. 50% is 0.5. 1/2, 1 divided by 2 using calculator is 0.2. So you see 0.5 is greater. -1/5 to power 0 will be equal to 1. And this side is equal to -1. Is 1 equals -1? So no, this expression is false. Solving inequalities is just like solving linear equations. Let's do question 25. Here we have x minus 3 is greater than 10. To solve this, we need to have x alone on a side. Then we send this -3 to this side. It will be positive, so x is greater than 10 plus 3. It means x is greater than 13. This is 25. Let's do 30. 10 is less than or equal to, that's how we read this, the difference between this sign, and this one, or this one. This one, we read it like 10 is less than or equal to 2x minus 6. But this one, we read it like 3x minus 4 is greater than. There is no equal with it. But this one, there is equal with it. 4 minus 2x is less than or equal to 2. 30. 10 is less than or equal to 2x minus 6. Then to solve this, we need to have x alone on a side. Send this -6 to this side, it will be positive. Then 10 plus 6 is 16, is less than or equal to 2x. Then to get rid of this 2, we need to divide both sides by 2. Divide by 2 to get rid of this one. Then 16 divided by 2 is 8, is less than or equal to x. To do 38, 4 minus 2x is less than or equal to 2. 4 minus 2x is less than or equal to 2. Okay, to solve this, firstly, whenever you see the x is negative, it's better to send the x to the other side. It becomes positive. Then 4 is less than or equal to, this 2 is on its side, plus 2x. Whenever you see negative x, it's better to send it to the other side to become positive, because dealing with positive is ways easier than negative. Then we need to have x alone on a side. Then we send this 2 to the side, becomes negative. 4 minus 2 is 2, less than or equal to 2x. So it's clear that x is equal to 1. Why? Because when we divide both sides by 2, to divide 2 is 1, is less than or equal to x. There's another way. If we don't like send x's to the other side, then there's another way. Method 2 for this question, this is method 1, m1, and here is m2. 4 minus 2x is less than or equal to 2. Then we send this 4 to the side. It becomes negative. Then we will have 2x, negative 2x is less than or equal to negative 2. Why? Because we will have, from this we will have 2 minus 4, which is equal to negative 2. And this negative 2 is this one. Now both sides are negative. If we multiply both sides by negative 1, that's how we remove negatives, then the negative will be removed on both sides. But one important thing happens here. That's what makes inequality a little bit different from equations. When we multiply both sides by negative, the sign changes. The sign is facing the right side, then it will face the left side. Let's see the results. After we multiply both sides by negative 1, we will get 2x is greater than or equal to 2. From this, we get x is greater than or equal to 1. This result is exactly the same as this one. Here, x is greater than or equal to 1 because the symbol is facing x, means x is greater. Here, the x is on the side, but the symbol is still facing x. It means x is greater than or equal to 1. So remember, whenever you multiply both sides by negative 1, the sign changes. Look, the sign was facing right side here, and it's facing the left side in this step after we multiplied everything by negative 1. Okay, now let's move on to question 39. Question 39, we have 3x minus 1 is less than 2, 1 minus x. This is question 39. Now, whenever you see brackets, it doesn't matter are you solving inequalities or equations. We have to expand the brackets first. Then 3 times x is 3x. 3 times negative 1 is minus 3. The symbol, same. 2 times 1 is 2. 2 times negative x is negative 2x. Now, no brackets. All you have to do, keep letters on the side, numbers on the other side. Now, we have to send this negative 3 to this side. It becomes positive 3x. And this negative 2x to this side. So let's mark them. This negative 2x goes to this side because we want to have x's on the side. And this negative 3 comes to this side. So this is negative, it will be positive. Then that's how it looks. 3x plus 2x is less than negative 3 comes to the side will be positive. 2 plus 3. Now, 3x plus 2x is 5x. Is less than 2 plus 3, 5. How can we get rid of this 5? We need to divide both sides by 5. That gives x is less than 1. You can solve the other questions yourself. Then check your answer with the answer keys. 40, we have 7 minus 3x is less than 0. Minus 3x is less than 0. Then how can we have x alone on the side? Basically, we can send this negative 3x to the side to become positive, which is the easier way, or we can multiply both sides by negative 1 to make the x positive. We use the easier way, send this negative 3 to the side, so 7 is, because it's negative, it went to the side, becomes positive. Then how can we get rid of this 3? We divide both sides by 3. It's fine to leave your answer like this. 7 divided by 3 is less than x. Or you can divide these numbers using calculator and write the answer as decimal. Using number line, it's quite often to use number line while you're dealing with inequalities. So there are two types of number line in inequalities. The first one is like this. The dot is, or the beginning of the line is open. And the second type is like this. The beginning of the line is closed. What's the difference between them? To write this number line as an inequality, we will say we consider all of these numbers, we consider all of them as x or y, or any other letter is fine. Then this symbol means greater or less without having equal with it. This one is for the open one, and the closed one has equal with it. It means this or this. The closed one has this equal with it. The open one, it's all about this tiny line here. The closed one has this line. The open one doesn't have this line. Now, we represent all of these numbers on the side as x. Look at these numbers. Are they smaller than 4? Yes. So it means x means all of these numbers are smaller than 4. Since this dot is open here, we don't have equal under this symbol. This side, the dot, the beginning of the line is closed, and we consider all of these numbers on the side as x or y, any other letter, fine. So x, all of these numbers are x. Then what's special about these numbers? Are they greater than -2? Definitely yes. So it means x means all of these numbers are greater than or equal to, just because of this closed, we added the sign because of this closed, we have this tiny line under the symbol, x that represents all of these numbers are greater than or equal to -2. This is the only difference between closed beginnings of the line, and the open ones. The open doesn't have this tiny line under it, and the closed have. Sometimes we have number lines like this bordered on both sides, so we can represent this by using two inequalities and then combine them in one. Here, to write an inequality to represent this part, we will write -1. All of these numbers are, let's name them x, a, b, c, whatever. These numbers are greater than -1. So greater than or equal to because of the dot x. This is the first part of the inequality. The second part of the inequality, using the side, we use to call all of these numbers together x. Then x means 0, 1, 2 are less than 3. Now to combine this, we have x repeated twice. So we try to write only one x between them. Then -1 is less than or equal to x, and x is less than 3. That's how we represent this type of number line. This is the third type of number line. Then these questions from question 1 to 25, it's exercise set 16. Question 1 to 25, we need to solve the inequality, then represent the answer on number line. 2x plus 1 is greater than 11, so let's solve this. 2x plus 1 is greater than 11. To solve this, we need to send this one to the other side. It becomes negative, so that gives 2x is greater than 10. Then divide both sides by 2, y2, because we need to get rid of this 2. Then it gives x is greater than 5. To write this as a number line, so simply you just draw a straight line, mark 5 on the straight line. I say this is 5, and x is the numbers that are greater than 5. So my number line will look like this. Since there is no equal with it, the beginning of the line is open on 5, and x is greater than 5 means these numbers. So simply you can just do it like this. It's okay to mark some more numbers, like here is 4 on the number line, here's 5, here's 6. It's fine. To the question 2, make sure to take notes while I'm explaining. 3x minus 4 is less than or equal to 5. Then 3x minus 4 is less than or equal to 5. Firstly, we're going to get rid of this negative 4, so it will be positive when it comes here. 3x is less than or equal to 9, because 4 plus 5 is 9. Then divide both sides by 3. That gives x is less than or equal to 3. Now, to represent this on a number line, draw a straight line. Then mark 3. Since there is equal with the symbol, the circle, the beginning of the line on the 3 is closed. Now, should we go to this direction or this one? Let's look at the x. X are the numbers that are less than 3. So it means these numbers on this side are less than 3. Because on the side we have 2, 1, 0, and the negative numbers. So all of the numbers on the number line on the side of 3 are less than 3, and the dot on the 3 is closed, so it means it's 3 is greater than or equal to all of these numbers on the left side. Question 3 has the exact same idea as question 1. Now let's do question 6. What if we have expressions on both sides of the inequality? Then that's how we deal with it. It's the same as solving equations. We need to have x's alone on a side, numbers on the other side. Done. 8x minus 1 is less than 5x minus 10. Then it's better to send this 5x to this side because the 5x becomes negative, but with the 8x, the final result will be positive again. It's okay if you send the 8x to the side, but in this case you will deal with negatives, which is not quite easy. Then let's rewrite it. We will have 8x minus 5x on the side, which is less than negative 10 plus 1. Why plus 1? This one is negative here, it goes to the side, becomes positive. Now 8x minus 5x is equal to 3x, which is less than 9. How can we get rid of this 3? By dividing both sides by 3. Divide 3 both sides, then it gives x is less than 3. X is less than 3. As inequality, it will look like this one, but this time the beginning of the line on 3 is open. Why it's open? Because there is no equal under this inequality. Why there is no equal? Because in the question there is no equal, and we follow the question. Then x covers these numbers that are less than 3. Look, rated x is less than 3. 3 is greater than x, so it goes to the side. And it's open because there is no equal under it. Question, it looks a little bit different. Let's do 15. You can pause the video if you want to copy in your copybook. Now question 15. It looks a little bit different from the others. Negative 3 is less than or equal to 3x, and it's less than or equal to 21. Then look at them. Because of this 3, we will divide the whole inequality by 3. Divide everything by 3 to have x alone. Then negative 3 divided by 3 is equal to negative 1. It's less than or equal to 3x divided by 3 is equal to x, and 21 divided by 3 is equal to 7. Now we need a bordered one. On the number line we mark negative 1. Here, let's say here is negative 1, and the beginning of the line is closed on negative 1 because of this, and we mark 7. Let's say 7 is here. X is the numbers, covers the numbers that are between negative 1 and 7. So here is the inequality. That's how it looks. X covers the numbers that are between -1 all the way to 7. You can draw each one separately, but on the same number line. Firstly, you can draw this, which is this part. Then draw this on the same number line, which is this part. Then as you see, the common part is the answer. 24x is less than 3x minus 1, and it's less than 2x plus 7. Now to solve this, firstly we can subtract x from all the parts of this inequality, minus x. Minus x, then you will see here x minus x is 0, is less than 3x minus 1. 3x minus x will be 2x minus 1. 2x minus 1 will be x plus 7. Now we got 0 is less than 2x minus 1, and it's less than x plus 7. We ignore the 0 side, so 2x minus 1 is less than x plus 7. But we remember the result of these two inequalities are greater than 0, so it means they must be positive, because only negative is less than 0. Now to solve this, we need to subtract x, or send this x from the side to the side. It becomes negative, so 2x minus x is x. This negative one goes to the side, becomes positive, is less than 8. 2x minus x will be x. 7 plus 1 will be 8. X is less than 8 is the solution. Can x be more than 8? No. If we put more than 8, for example 9, it doesn't satisfy this inequality. 2 times 9 is 18, minus 1 will be 17. 9 plus 7 will be 16. So we cannot have the side less than this one according to this symbol. So the solution is x is less than 8. To represent this on a number line, and the x must be more than 0, we remember this. We ignored, but it still affects the answer. Now to write this in a number line, a straight line, mark 0, and the beginning of the line is open at 0. This is 0, and mark 8. The line is also open at 8. Then between them, we can just represent them as a straight line between these two open circles. Then that's how we represent it on number line. X is between 0 and 8. So x, which means all of these numbers between 0, which are 1, 2, 3, 4, 5, 6, 7, all of these numbers between 0 and 8 represents x. Now this question is kind of word problem, or it's the condition on the variable. 3a plus 1 is less than 20, while a is a positive integer. So if we put any negative here, the result definitely will be less than 20. The question wants the positive answer for this one. It means we have greater than 0 on the side. Why? Because the question says a is positive. Now, 3a plus 1 is less than 20. Then to solve this, firstly we send the 1 to the other side. 3a plus 1 is less than 20. Send this one to the other side, becomes negative. 3a is less than 19. So divide both sides by 3. A is less than 6.33. If a be positive integer, so it means a is 6. A could be 6. Look at the question again. What is the solution? A is less than 6.33. Since A is integer, we have to remove the decimal side. A is less than 6. We got A is less than 6.33. Then, since the question says A is a positive integer, so A could be 6.33. So the closest integer to this one is 6. But remember this, 6 is less than 6.33. So A could be 6 or less than 6. This is the solution of question 26 according to the condition. These inequalities, you just normally solve it. After you got the solution, then think about the condition. Now let's do 30, for example. Question 30, 0 is less than 3x and it's less than 40. Now, how can we solve this? Firstly, we divide all of them by 3. 0 divided by 3 is still 0, less than x. And 40 divided by 3 is 13.33. So what's the closest integer? It's not about integer, it's about divisible by 5. So x could be 10, because 10 is divisible by 5. Look, this is the solution. Now think about the condition. The question says x is divisible by 5. So x could be 5, because 5 is greater than 0 and it's less than 13.33. Or x could be 10. Why we don't accept 15? Because 15 is not less than 13.33. So the solution for question 30 is just 5 and 10. Because these are the only numbers that are divisible by 5 and they are less than 13 and they are more than 0. 35, a over 2 plus 10 is greater than a, while a is a positive even number. So let's solve this inequality. A over 2 plus 10 is greater than a. Then to do this, we send this a over 2 to the side. So 10 is greater than a. A over 2 means half a. A over 2 means half of a. And this side we have a. So a minus half of a, what's remaining is half of a, which is a over 2. So 10 is greater than a over 2. How can we get rid of this 2? Multiply both sides by 2. Then you see 20 is greater than a. 20 is greater than a. And the question says a is a positive even number. Positive even numbers that are less than 20 are 2, 4, 6, 8. So the solution set for a is, because 0 is even and it's not negative, it can't be 0. So it is 2, 4, 6, 8, 10, 12, 14, 16, 18. Because all of these numbers are positive even numbers that are less than 20. To represent this on a number line, so you just need a number line and mark the numbers and each one with a closed mark. Write the smallest integer n for which 4n is more than 90. For this one you just have to think 4 times 5, 5 is a positive integer and 4 times 5 is 20, so n is 5. Because if we put 4, 4 times 4 is 16, 16 is not more than 19, so it's 5. 41, 4 over 9 is less than q and it's less than 5 over 9. Find a simple fraction q such that, okay, how can we find a fraction between two other fractions? Since they have the same denominator, then to get the solution, this is not very reliable to write points. What's the number which is between 4 and 5? Simply we can say 4.5 is between them over 9. It's not reliable to have point on fraction. Then by multiplying both by 2, we will get rid of this 0.5. We will have 9 over 18. So 9 over 18 could be equal to q because it's between them. This fraction is equivalent to this one. So this fraction, surely we know it's between 4 over 9 and 5 over 9. Then this fraction is equivalent to this one. Of course, q could be this fraction. Then the graphical display is for the next tutorial. Feel free to pause the video, take notes, write the answers, and try to solve some questions yourself and check your answer with the answer keys from the back of the book.